Bonjour et bienvenue à Tearing Down the Walls, Closing the Gap Between Outdoor and Indoor Navigation. Je vous présente Anne Van Closter.
That's right.
De l'Université de Ghent. Madame Van Closter est présentement au doctorat en recherche sur Geography and Survey, c'est ça?
Yes, Geography and Survey.
Elle se spécialise dans la cartographie 3D intérieure et extérieure. Donc je lui laisse la parole. La présentation est en anglais. Merci.
Well, ladies and gentlemen, good afternoon. Thank you for the introduction. So I'm a second-year PhD student from Ghent University in Belgium. I'm very happy to be here in Canada and talk to you. My presentation will be about the integration of indoor infrastructures for navigation and for pedestrian navigation. So this is the outline of my presentation. I will shortly introduce the applications for navigations before I go to a route planner review, and I will conclude with a product to market implications. So I'm sure every one of you is familiar with outdoor applications, outdoor navigation applications, GPS systems. But we've seen lately that there have been some efforts for indoor navigation, and this was focused on 2 points. First of all, technologically, people have started to do research on indoor positioning, indoor tracking, using, for example, Wi-Fi, RFID systems. And secondly, indoor data models, three-dimensional data models, have gotten increasing attention over the years now. In this presentation, I will focus on pedestrian navigation. Pedestrian navigation compared to car navigation is a bit different. Pedestrians have specific requirements. The context is different. The scale level is micro scale level. They walk instead of drive a car. So the context the environment is different. And more importantly, as pedestrians, we move between indoor and outdoor environments seamlessly without any trouble. So we can expect, or we should expect, that the navigation applications we use in our outdoor world, we can use them also in our indoor world, so we can extend the outdoor navigations to the indoor world. So the goal of this research was to give a bit of a state-of-the-art, a review, and to what extent the integration of indoor infrastructures has already been done for navigation, and we based this review on what common route planners do. I say common route planners because common for the area, the geographical area of the query we've done. Indoor infrastructures, I mean publicly available infrastructures, shopping centers, but also underground structure, passageways, everything that is not outdoor basically, and pedestrian navigation. So we wanted to check if the route planners integrate on 2 things. How do they handle indoor data? And secondly, how do they work with the link between what the user input is and how he translates that to the network? So first, on the use of the indoor data, we've done several queries in several route planners. This is an example in Brussels where we wanted to navigate between 2 streets, and in between there is a public gallery, an open public gallery. And as you can see, 4 of the route planners actually use in their shortest path calculations the indoor infrastructure as part of the shortest path. On the other hand, Bing and Google Maps don't do this. Bing doesn't even recognize the gallery as part of a spatial data set, and Google Maps only gives a text label, so the indoor network itself is not part of the data set. Okay. Doesn't go anymore. Okay. A second query was in the city of Seoul in Korea. We only have used their 2 route planners, basically because all the other route planners didn't have detailed information of the city center of Seoul. As you can see, the example was that a pedestrian tries to cross a street, which is very busy, so he has to use an underground passageway. And Google Maps only indicates with an arrow how the pedestrian should go without giving additional routing instructions. While Naver is the local Korean route planner, is very specific in how the pedestrian should go. The route planner states the exit and the entrance of the underground passageway, so it's very easy as routing instructions for the pedestrian to use. So from these two examples, we can already see differences in data availability and in the level of detail of the integration for indoor infrastructures. On the availability of the entrance information, we wanted to test if the information about indoor networks was complete. So we wanted to see if all the exits and entrances were part of the spatial data set. And we're back to the first example with the public gallery in Brussels. We wanted to navigate from the main station in Brussels to the gallery, and it's actually connected with an underground passageway. So it's very easy for pedestrians to go. But as you can see, there's only one route planner who knows that. That is the Open Route Service, which makes use of the OpenStreetMap data. And all the other route planners give suboptimal routing. Bing, again, can't give a route for this query because he doesn't know the gallery. A last example on the use of indoor data is a multimodal example, again in the city of Seoul, where a pedestrian wants to go to some place using the blue subway line on the bottom. Google Maps, again, gives very limited information, and Naver, again, gives the exit and entrance information. What the point is here is that in reality, the information Naver gives is not the shortest. It's maybe the shortest path, but it's not the easiest path, because under the ground, the walkway is you have to descend a couple of stories and then go up again. So it's the three-dimensionality of the underground structure is here not taken into account. So from these examples, we can learn that most of all we have trouble with incorporating indoor data, probably due to a lack of available indoor data. And this can be due to the data gathering that it only has just begun. And of course, the geographical area of the query. These were just a couple of examples. We did more examples, but it's still related to the commercial value the route planners have, and if the area is an important area for them. When there is available indoor data, there is a difference in the level of detail they give back to the user. The underground structure have an even more pronounced problem, and the three-dimensionality of the indoor data is never taken into account. A second thing I wanted to discuss was on the indoor address matching. This is, again, the example in the gallery in Brussels, where we wanted to navigate in the gallery. The start and destination point are in the same gallery. On the top rows is the destination point is on the same network edge as the begin point. On the second row, the destination point is on a different edge from the network. And so you can see only in the second example, the route planners were able to actually give information about how to go. And in the first example, there was a varied solutions for this, and none of them were actually able to give the user a detailed description of the route they had to take. With the indoor address matching, we also wanted to check if the route planners make a difference between exit choice. This is in Ghent, the main station, and it has two exits, one to the north of town, and one in the north and one in the south. And we did two queries with each route planner. The first rows are actually with a query where the user wanted to go to the north of town, so using the north exit. And the second row is always the example where the user wanted to go to the south of town using the south exit. As you can see, no route planner actually differentiated between the destination of the query, and it only has one link between the address and the point on the network itself. So from this, we can conclude that the indoor address matching is both a problem in outdoor navigation and in indoor navigation. Outdoor, there is only one link between the exit point and it's not linked to the destination of the query, which results in suboptimal routing. And on indoor, the problem for indoor is that when there is network information available, the solutions are quite diverse, going from linear interpolation on using projections on outdoor network, or not even able to calculate routes. So what does this mean for the market? Is it actually feasible to integrate indoor with outdoor navigation? So first, on the data acquisitions and standards, current route planners are actually a mix of global providers like Google Maps and Navtag Teleatlas data, mixed with local information, and they all have their commercial interests. So I'm sure they will, when they want to integrate indoor information, they will focus this on their points of interest, where the users mostly are. For the raw data acquisition, we cannot use the outdoor techniques, the outdoor acquisition techniques, so no aerial images or mobile mapping vans indoor. But we have to realize that we already have so many information from our indoor world. We have CAD plans, we have city GML models, very complex 3D models from various applications. The problem there is that there is such a diversity in the quality and the coverage. Every source is different, scale level, the data structure, so it's not so easy to integrate the information we have in a very structured way. And there is also no standard for indoor data, although in Germany people are thinking of that, doing that. And then from the raw data, we have to transfer that to the network. And we have the problem that transferring the raw data to a network has to be built on a very mathematically sound framework, and we also don't have that yet. Concerning the indoor geocoding challenges, so we want to translate the user input, any input, to geographical coordinates. The requirements for geocoding are: you have an input source, you want some kind of output, but you base yourself on a reference data set, which in outdoor address matching is mostly Tiger or any other data set available. We have a processing algorithm, which is, for example, a linear interpolation. And for indoor, when you take this to the indoor world, the problem is that there is a non-existing uniformity in indoor addresses. When we do a linear interpolation outdoor, they assume that the house numbers will have a kind of a structured way. And indoor, the numbers are very varied. There is no structure at all. It's diverse. For every building, it's different. So this might need a different processing methodology or some other kind of way to handle this. And the problem is also, second problem is the reference data set. We already have so limited indoor data, so how are you going to use, or what are you going to use as a reference data set? So the feasibility of the integration, I think that there is not really feasible to do complete indoor data gathering, but I would say that small data enhancements like we could see in the neighbor application with pointing out exits and entrance can already help increase the user, or increase help the user with navigating and using indoor infrastructures. When we would gather indoor data, I would focus on large, stable transportation infrastructures with a lot of people use it over time. It's a very stable infrastructure. The three-dimensionality of the aspect, I think, is important, especially for pedestrians. We want not always to walk the shortest way, but also the easiest way, and three-dimensionality is there an important aspect. Public participation, I would say similar to how OpenStreetMap and now more and more Google Maps and other route planners let people actually upgrade and change data and make it better. I would say that that might help the gathering or the gathering of the indoor data, and maybe use the existing indoor information. Although that is not so easy because of the diversity and the differences between that. And then we have the problem of the Geocoding, I think there is a need to improve the geocoding methodologies for indoor. And this is only about navigation, the data and the user input, the user descriptions, but for having a full navigation system, we also need the positioning techniques, which is also still in a development phase, so there is also a need for that. And this was the end of my presentation. I thank you, and if you have any questions.
Des questions? Pas de questions. Et merci beaucoup.
Okay.